Well, hi everyone. Do you hear okay? Right. Well, hi everyone. Thanks for joining this talk, building your own pivoting law and a starting point for internal network exploration. Well, as you presented before, I'm Francisco Canteli. I'm the head of offensive security at the company Metrics. I also hold some international certifications like OSCP, BSCP, among others. I also like to speak at different conferences, so that's why I'm here. And I also like to play CDA in my free time, such as hackathons. Well, let's review the agenda for today. We are gonna start with a brief introduction, okay? I will start explaining what pivoting is. Of course, we are gonna discuss about the methodology that we are gonna use when we need to perform a pivoting into an internal environment. After that, we are gonna discuss about some of the most common pivoting tools that we could use. Also, I want to talk about the comparison of these tools. And of course, I'm going to close the presentation with some conclusions. So, well, let's get started. First, the introduction, okay? The main reason of this talk is not only to give you guys the concept of how you could start to pivoting using different tools, but rather the idea is that you go with a tool, with a lab that you use to try your own tools, right? For example, if you found that there is a new tool that you could use for pivoting into an internal environment, you could use this lab just to learn and try if this tool is working fine or not. Okay? Well, what's pivoting? Okay? Pivoting is essentially a technique that we will use on a penetration test to gain access to different systems or networks that are not directly accessible. Okay? Once we compromise the machine, we will use this machine as a jump-off point to access another machines or internal networks. Okay? That's it. Oh, that's okay.
Okay,
No problem. Well, what's pivoting? Okay. As I said before, pivoting is a technique that we will use on a penetration testing when we gain access to a machine to pivot to the internal network, right? We will use this compromised machine as a jump-off point, a jumping-off point to access another machine or to access another internal networks. What's gonna be the methodology that we're gonna use? Okay. Well, the first step, we will need to have the first compromised machine. We will call it the pivot point. The second step, of course, we are going to perform a recon on this compromised machine. We are going to eventually, if needed, perform privilege escalation on this machine. We're going to identify the network interfaces on this pivot machine. Also, we're going to identify useful tools that are installed, okay? This is related to the technique living off the land, right? We're going to perform a ping sweep. I'm going to deep dive in this in a second. And eventually, depending of which tool we are going to use, we're going to perform a port forwarding, okay? Right. Let's assume this pivoting scenario, okay? This is the pivoting scenario that we will see on the lab. We will have our attacker PC, right? And then we will have our first compromised machine. That will be our pivot point, right? That is shared PC. As you can see here, hold me a second. You could see that this pivot machine has two network interfaces. One that ends with .1/24, and the other one that is ending with .11.1/24. The attacker and the pivot machine is connected on the same interface, but shared PC, this pivot point, has access to another network, right? Okay. Let's explain now a concept that is called port forwarding, okay? Port forwarding will be essentially a technique that we will use that will allow the attacker to access an internal network through a compromised machine, okay? And there are three possible techniques of port forwarding, okay? There is local port forwarding, remote port forwarding, and dynamic port forwarding, right? Great. The first one, the local port forwarding technique, will be the technique that we will use when we need to redirect the port from the attacking machine to the compromised machine and then to the target machine, right? Well, an example of when we need to use this technique will be when we need to access to an internal website, right? That we could not normally access. Let's see an example, okay? Here we have our attacker PC, right? And we have here the website, the internal website that we couldn't reach out, right? So we will use a port forwarding technique to tell, for example, receive all the connection redirect all the connection received on shared PC, the pivot point, on port 8080 to the website on port 80, right? This is a common scenario when we could use a local port forwarding technique. The second method is remote port forwarding, right? We will use remote port forwarding when we need to redirect. It's the opposite, right? When we need to redirect the target machine to the compromised machine and then to attacker machine. A common example when we're gonna use this technique when we need to receive a reverse shell, right? Let's an example, okay? In this case, we could assume that we have compromised the website, okay? So we need to create a reverse shell, right, to our attacker machine. So we will need to perform a reverse port forwarding on shared PC. What we are gonna do is redirect all the connection received on shared PC at port 5555, as you can see here, okay? And then go to the port 4444 on the attacker PC, right? So we could receive the reverse shell connection on the attacker PC. Great. And the last one is the dynamic port forwarding. Okay. Dynamic port forwarding will create a SOX5 tunnel, okay, that we will use between the attacker and the compromised machine. This will allow the attacker to access multiple ports on the internal network, okay. It's important to note that SOX5 is a layer 5 protocol. Keep this in mind. We will deep dive in what this is important in a minute. But the main reason is that some of the protocols may not work with SOX5 due to compatibility issues. So we're gonna see what is the trouble here, right? An example of dynamic port forwarding, you can see as this graph, this creates a tunnel, right, to the other network that are accessible to shared PC, as you can see. So, for example, we could also, if we have an internal website, we could also access it through the tunnel in this case. Great. So, as I told you before, what is one of the problems here, right? Can it ping through a SOX tunnel? Well, the short answer is no, okay? This is one of the limitations that we have. That's why in the methodology, I first explained that, for example, we would perform a ping sweep. Because if we are gonna use a technique that requires port forwarding, we can't ping through the SOX5 tunnel, okay? That is because SOX works on layer 5 and ICMP works in layer 3, sorry. Well, can I scan ports through SOX tunnel? Well, the short answer is yes, but with limitations, okay? We will need to use the ST flagging nmap. This will indicate that we are going to perform a full TCP scan. But the problem with that is that this type of scan, of course, is slow. So what happens, of course, if we don't use this flag, is essentially it won't work. So that's one of the main problems that we have if we are going to create a channel, right? For example, a dynamic port forwarding, and we would like to use this to perform pings on the new internal network. If we like to, I don't know, perform a port scan, it will be slow, right? That's one of the limitations. Well, let's now discuss about the pivoting tools that we have. One of the most common and most mainly known tools is Chisel, right? Chisel is essentially described as a TCP UDP channel transport over HTTP and secure via SSH. It's a single executable, right? So we could use the same executable as on a client. We will see that in a minute. Also, it's written in Go. and it's useful to bypass firewalls, although this is because of the uses of HTTP, but essentially it will although it can be used to provide secure connections to your point network. Okay, here you can see a graph of how Chisel works essentially. As you can see here, it creates a tunnel between the Chisel client and the Chisel server, an HTTP tunnel, and encrypts using SSH. Great. So we have the two modes of Chisel. As I told you before, you have the Chisel server, well, the same binary, right? That is, you could use it as Chisel server, or you could use it as Chisel client, right? Chisel server, of course, will allow us to receive connection from more clients. You can see that is pretty simple. That you could start the Chisel tool, use -p and specifying the port where you're going to start the Chisel server. And of course, you have the Chisel client, right? The Chisel client will allow us, of course, to connect back to the Chisel server with the client and the specified type of port forwarding or SOX proxy that we want to create, right? Here you can see, first you have the Chisel, you have to specify that you are going to use the client mode, and then you have to specify the server's IP and the port that we find before, right? Of course, you also have to specify the remotes. These are tunnel connections that we will use, right? That we just discussed before, the port forwarding. We are going to see an example in a minute. Also, Chisel has something that's called reverse mode, right? This mode essentially allows clients to connecting back to Chisel server to define reverse tunnels, okay? So connecting clients on this mode can open listening ports on the machine where the server is running, okay? This will be useful because, the server will listen and accept any connection, and this will be proxied through the client that specifies the remote, right? As you can see here, you can start a Chisel in reverse mode using tac reverse. You can start the Chisel server, right? Let's see a demo of a local port forwarding in Chisel. Let's me a second. There it is. Well, as we are seeing here, this is the scenario that we have seen before. Okay. I'm explaining exactly that. We are gonna perform a local port forwarding to access to this website, right? As you can see here, I have the attacker PC and the shared PC that will be the pivot point, right? And you can see that I will use the Chisel server in reverse mode on the attacker PC, and in the shared PC that will be the pivot point, I will create a local port forwarding rule. Okay, let's review the rule in a minute. Right, first we're going to specify here the IP of the attacker PC. Right, then the port, as you can see here, 8000, the same port as Chisel server, and then we're going to specify receive all the connection received on the attacker at port 5050 redirected to the website IP, internal IP on port 80, right? That is the command translated, essentially. That's what the command does. As you can see here, we are going to create this local port forwarding rule, right? Exactly what with the port 5050 to the IP of the website in the internal website and to the port 80. We have created the rule, as you can see, was created successfully. And after that, we're going to try to access from our attacker PC to the website. And you can see here, you can access to the internal website, right? Perfect. Great. Let's see an example of how we could perform a remote port forwarding, in that case, using Chisel, okay? Again, let's remember, there it is. Let's remember that we have this scenario. It's not good. Oh. There it is. Okay, let's remember the scenario, right? We're gonna have compromise. We are gonna assume that we have already compromised the website server, so we are gonna need to get a reverse shell on our attacker PC. Let's review the scenario. Perfect. Well, now going back to the server, we have the three machines, right? We have the web server that is compromised. In this case, we are going to assume that we have already compromised it. We are going to have the pivot point that will be on shared PC, and also we will have the attacker PC that will be our PC, right? Well, the first command, of course, we will start the chisel server at our attacker PC. After that, we are gonna create the rule for chisel client, right? In the chisel client, we are gonna specify, as you can see here, redirect all the connections that are received on shared PC on port 5555 to our attacker PC on port 4444, right? As you can see here, is the attacker. That is attacker PC IP that is on the same network of the shared PC, right? As you can see here, we have created the tunnel successfully, and we are gonna use netcat for listen on our attacker PC to the reverse shell, right? So we are using netcat to listen to the connection, and as you can see here, we are gonna use this command to establish the reverse shell from the web server. And as you can see here, we are not specifying the attacker PC. We are specifying the shared PC, right? So here on the command that we will use to establish the reverse connection, the reverse shell, we will use the shared PC IP with the port 5555, and then shared PC will redirect this port, this connection to the port 4444. And you can see here we got the reverse shell, right? Perfect. And let's see dynamic port forwarding demo, okay, with chisel. Okay, remember the scenario here. We have the attacker PC. We are gonna create a tunnel. For example, we are gonna use this tunnel to access the website. Okay, so here we have the scenario, we have the attacker PC, we remember that shared PC has two interfaces. Of course, the main step will be starting, well, in this case, we are going to perform a ping sweep, right? Why we're going to perform a ping sweep? Because we want to know what other hosts are up on this new network. So if we come here to the pivot point, of course, in that case, I didn't do that in a video, but the first thing we will do is execute an ifconfig command, see what interfaces are up, and if you see that is one interface that you are not with another IP that you don't know, essentially, you will know that you have to go to that way, right? So in this case, we are gonna perform a ping sweep on this set of IP. And we could see we'll have the router IP, the machine IP, that's the IP from shared PC, and another IP, okay? As you already know, this IP, of course, is from the web server. But we're gonna start now the chisel server, again on our attacker PC. And after that, we are gonna create a SOX tunnel, okay, through port 1080, okay, using chisel. As you can see here, let's me a second. Perfect. We just created the tunnel. Then we are gonna use proxy chains to perform some actions between using this tunnel, right? So here we are gonna configure on the attacker PC the dual proxy chains. Okay. Here we are configuring the dual proxy chains to establish this, to use this tunnel that we just created. And as you can see here, we are just configuring that. Perfect. And after that, for example, we are gonna use proxy chains to perform an nmap to this new host. right? That we couldn't reach out without the tunnel. Here you could see that all the traffic is proxied through this tunnel, and we get the answer. We perform the Nmap through this host, right? And in the last step, I just opened Firefox just to show you that you could also use this tunnel. Important, I open Firefox, but of course using proxy chains. Please notice that, because this will proxy all the traffic through the SOX tunnel, essentially. So as you can see here, now we could access to the website, right? Well, also we have another tool that is being more popular in the last time, right? That is Ligolo NG. Okay, Ligolo is a pretty interesting tool, right? Because, well, it's defined as a simple, lightweight, and fast tool for pentester. It allows established tunnels from reverse TCP DLS connection using a tooling interface. And the interesting stuff here is that Ligolo will create a tool interface, but you will not need to have a SOX tunnel, okay? That is amazing because, for example, as I told you before, normally when we perform a port forwarding, we are limited to some action. For example, we cannot ping. We have to use unspecified flags during our port scans, right? So how does it work? Well, essentially, instead of using SOX proxy or TCP UDP forwarders, Ligolo creates a user and network stack using CB25, okay? All the packets sent to this interface are translated and then transmitted to the agents on remote network, right? Well, let's see a demo of the dynamic port forwarding on Ligolo. Okay. Here we have the attacker machine. The first step that we are going to perform, of course, is we are going to create this tool interface, right? As you can see here, again, we have the attacker PC, two attacker PC terminals, and the shared PC pivot point, right? Here we are going to create the TAN interface. We are going to set it up, essentially. Here we are setting up this TAN interface that we will use. And you can see that that's created successfully, right? The next step that we are gonna perform is essentially to start our proxy or our attacker machine, right? In this case, we are gonna use tag self-serve just for having an easier demo, because it's an internal demo, right? But this certificates is used, of course, for encrypting the traffic between the proxy and the agent. And what we are going to perform here is a connection to the from the pivot point. Okay, we are going to use the agent to connect back to the attacker, and then we are going to create the dynamic. It's not a dynamic port forwarding, but we will use it as a kind of dynamic port forwarding. Okay. As you can see here, we have already started the Ligolo proxy, and then we are going to connect back here to the attacker's PC, and this is the default port that Ligolo use, okay? And we are using tag ignore cert again, just for demo reasons. And you can see here we have already connected back to Ligolo. We're going to see what sessions that we have. We have the session of this machine, this shared PC that got connected to us. So then we select this session. And after that, we are gonna, in our attacker machine, we just only need to add the specified route that we will need, right? In this case, as you can see here, we will need to add a route to this new network that we couldn't originally reach. So here I create a route that says everything that is going to 192.168.1.0/24 has to go to the Ligolo interface. So I just start this on Ligolo, and that's all set. Now, for example, we could ping using this interface. As you can see here, for example, we're gonna ping the web server, and you can see that from the Attacker PC, we don't have any of the limitations that we have on the normal flow, for example, using chisel or using a dynamic port forward. Perfect. Let's see a demo now of how we could perform a reverse port forwarding, right? Here we could see, again, we have the Attacker PC, we have the pivot point, right? And again, here we are gonna start the tunnel, right? We have already established the connection. Then we are gonna create a rule, right? That in Ligolo, that we will say redirect everything that the pivot point receive on port 5555 to our machine on port 4444. Okay, you're gonna see this in action. I'm just creating the rule, and here, well, a second. We just created the rule. And after that, we are going to execute again. This command will get a reverse shell to our machine, right? There I am establishing the listener on the Attacker PC. And after that, you also have there the command that we use to get the reverse shell, right? Perfect. Well, tool comparison. Well, essentially, if we would like to compare the tools, we would say that Chisel is very easy. It does not require sometimes minimal configuration. Ligolo, it's medium, requires some kind of setups. The detection evasion is very high with Chisel, right? Also, I added some other tools that you could use, like Couple Strike, Metaploid, SSH. Of course, the tools that you could use will be dependent of what you really need, right? But essentially, with Ligolo or Chisel are free options, open source, that are really great. Personally, I really like Ligolo because of this trouble that we have when we need to create a port forwarding. Okay, and well, let's show you the hands-on, right? Here is the link for the pivoting lab, right? This pivoting lab is a lab I will show you in a minute, but it's a lab that you could use to try and to practice, right? For example, again, the idea of this talk is not only just to let you know, to teach you guys how you could perform pivoting in internal environments, but rather also give you the tools that you could use. Again, you don't have to purchase some subscription to a CTF platform. You could use this that's open source, and you can try different tools, right? If you wanna try how Ligolo works, it works about over, I don't know, 6 or 7 hops, right? These labs have about 6, 7 hops, so you could try how the tool is performing on that, right? Okay. Oh, let's see the hands-on. Okay. Let me hold a second. Here it is. Here you can see the GitHub wrap, right? It's really easy to deploy, right? With Docker. If you use Docker Compose up, you click clone and you have it up all set. And you also will have a walkthrough that is in English or Spanish, that you could use essentially to give the guidance of how you could perform and you could resolve the lab, right? Let me show you just a quick demo, okay? Here also we have as you can see, this is the walkthrough, is the part of the walkthrough. The first thing that we are gonna do here, just to show you a little part, yeah.
May I ask how much RAM I need to run the laboratory?
How much?
How much RAM, memory, or like are there any? Will my laptop crash, or is it like?
No, I'm gonna be honest. I'm not sure how much RAM could consume, but honestly, I also run it on my M1 Mac that is from 20. Yeah, on my M1 Air Mac and works fine. But yeah, I never have any trouble with that because when you use it Docker, you normally, well, if you have it well configured, right? You normally have no trouble. But yeah, okay. Let's show you now how you could create a port forwarding rule using Ligolo and all that. Again, I know that we saw this before, but it's just to show you how you could use it on the lab. As you can see, on the lab you could connect directly to the bin. You have an OVNC option. So you create the tunnel interface, right? As you saw in the video. Here we created on the attacker PC. So, we create we set up this. Now we are setting up this interface. That we will use Ligolo, essentially. Give me a second. There it is. We have just created the interface, the tune interface that Ligolo will use to access to the other machine. And here we're gonna start the proxy or non-attacker machine. Oh, yeah. Pivoting, of course, we are gonna need to have the binary. There it is, perfect. We're gonna start it, great. There it is, perfect. And then we're gonna start the connection back to, here is the compromised PC, right? So here again, CD toolkits, CD pivoting, perfect. We are gonna create the connection. As you can see here, we have already established the connection. And after that, we are gonna use, first we need in Ligolo, let me show you sessions, okay? We are gonna see that there is the session that of the previous connection that we established. And after that, we are gonna, we are gonna create the route for this new network. Okay, let's show you something here that is interesting. If config, you can see here that that this machine has two network interfaces: ETH0 that has this other network connected, and ETH1 that has the same network that the attacker PC is connected. Okay, let's again connect back. Any session. Let's select the session. That's okay. Perfect. And now we are gonna create the rule just to traffic all the traffic that goes to that IP through the Ligolo interface. So let's paste that. Perfect. And then of course I have to start the tunnel. So I start, and that's it. So for example, again, if we need to ping to the machine, in this case the web server, we will see that it's working, okay? And we are not using some kind of SOX tunnel, right? And also if we try to access to this machine, if everything goes right, we could access to this internal website that without this, with Ligolo, we couldn't access. Okay, well, some conclusions. Essentially, Ligolo NG is more flexible than Chisel. Okay, it's essentially supports full TCP tunnel behind SOX, right? Chisel is simple and effective but limited to SOX proxy. And traditional tools are typically feature rich but normally are more heavy, eventually more detectable, and often expensive in their paid versions, right? So essentially, of course, the tool that you guys are gonna choose will depend on what you will need on the moment, but that's essentially it. So well, thank you so much for joining this session. And that's it. I don't know if there is any question, any doubts. Yeah.
What do you think of the web interface of Ligolo?
Sorry?
There seems to be like a new web interface for Ligolo.
For a web interface?
Yeah, a web interface. It's like on the GitHub.
Yeah, I'm not sure. I mean,
maybe it's like it might be something rather new. So maybe you don't have experience with it yet.
But what? I don't get it. Why do you need to use the
Yeah,
web?
just for like your experience, like when you use it. Do you prefer it over the terminal? Do you see any advantages over the web interface? Stuff like that. Would you recommend it after some time just using the terminal, or is it actually like a nice addition, getting a good overview? Or
you mean using Ligolo when we need to pivot to access to websites? I don't know if you get right.
no, it seems that it has now also like you can run Ligolo over the terminal, as you showed now. But there's also like a web server starting. Like there seems to be a new feature where there's a web server. If you like scroll up a little bit.
Okay.
This one. And it seems to like give you like an overview, and you can like pointy and clicky add stuff.
Oh, okay, I got you.
And I thought like maybe you already checked it out, and you could say like, well, I don't know. I would have liked it if it's more green or something.
Normally, I'm not gonna lie, I didn't try it. And normally, I'm one of the traditional type of guy that prefers to keep out the terminal. But yeah, I'm gonna be honest, I didn't try it because I really feel comfortable having my hands on in the terminal. But yeah, I will have to try it, right?
Thank you for the introduction.
Yeah, no problem. Well, I don't know if there is any other question, any other doubt. Oh, well, thank you so much.